Hey, Rose. For lesson 1.13 on building our own equation for word problems, I want to take a look at page 316, number 16. It is the steer problem. We have a 135 kilogram steer that gains 3.5 kilograms per day and costs 80 cents per day to keep. It says the market price for beef cattle is $1.65 per kilogram, but the price falls by 1 cent per day. When should the steer be sold to maximize profit? Okay, so I definitely want to maximize profit. I'm going to draw a quick sketch, and I'm going to make sure that profit is my dependent variable. Let's get that out of the way with a let statement. And make sure that you're practicing your let statements in your homework. It's not the kind of thing you want to be doing for the first time on a quiz or on a test. Let P of, I'm not sure what yet, represent profit in dollars. I don't think I want to do hundreds of dollars or millions of dollars or anything here. Okay. Now let's continue the question in English. To figure out profit for almost every single question, we're going to do the revenue minus the cost. This is going to help me split up these numbers in here. Only one of these numbers is related to a cost. Often students try like subtracting this from some other measure, but it's the only number given cost. All the other values relate to revenue. In this specific question, let me take this a little bit further and say, how am I going to figure out my revenue? How do I calculate how much I'm going to be paid for selling a steer? Well, I'm given information about mass and price. I'm not deciding how many cows to sell in this question. It's not like exactly like an orchard question. It's going to be the mass of the steer multiplied by the price per kilogram. Price per kilogram. Right. If I sell a heavier steer, I should get more money. If the price of meat is higher, I also should get more money. The balancing act here, and we can make a maximize revenue question out of this, is that if I sell right now, the price is as high as it's going to be because it's going down. But if I sell right now, I'm selling, I don't know, is this a skinny cow? Let's pretend it's a skinny cow. I could wait later and feed this cow, and then it would get fatter. Its mass would increase. So then I'm selling more beef. Doesn't that seem like a good idea? But maybe by waiting longer, the price per kilogram is going to drop. Maybe there's some sort of in between there that I can use. This should feel a lot like an orchard problem or a dance problem, even though the wording is absolutely different. Okay. Now the cost in here, I think it's just going to be the cost per day multiplied by the number of days that I wait. Number of days that I keep the cow. So that's another disadvantage in this question. Even without considering revenue, I can see that the number of days that I wait affects the mass and the price. But every single day that I wait, I also have to feed the cow and I don't know, bathe it. There's got to be other costs for cow maintenance that I'm not familiar with. Okay. Now, the variable that is kind of in control of mass and price right here shows up over here in this case. Again, let's imagine that it was a revenue question. I don't think I want to let my independent variable be the mass because I have no idea how I'm going to figure out the price per kilogram. I don't think I want my independent variable to be the price per kilogram because I have no idea how I'm going to figure out my mass. I think I can figure out that the mass and the price per kilogram both depend on the number of days to wait until selling. But I still don't have to have made that decision yet. I'm still going to suggest that we just take this a little bit further and put in the initial information that we have. That initially this steer weighs 135 kilograms. And initially, the cost, ignore that for now. Initially, the price per kilogram is $1.65. Let me focus on revenue first. If or let's say for every day that I wait, I see that the mass, the mass of the steer is going to go up. So I'm going to add a 3.5 multiplied by the number of days to wait before selling. There's my increasing factor. I'm going to predict the other factor should be a decreasing factor, like a decreasing linear relation. The market price begins at $1.65, but every day that I wait, the price falls by $0.01 or 1 cent multiplied by the number of days that I wait. And at this point, hopefully before now, I would have had an idea of what my independent variable is going to be, but you can wait until now before deciding it. Let P of N represent the profit in dollars, where N is the number of days. Number of days until when? Until or before we sell. Okay. Now, this would be my revenue function. If N is 0, that means I should sell now. If N is positive, that means I should wait a couple of days. If N is negative, that means that I should have sold a couple of days ago, which means that what I should do is sell now because the price is on the way down or my revenue is on the way down. This is a profit question, though. Let me make sure that I include my costs. The cost per day is fixed. That's 80 cents per day multiplied by the number of days that I'm going to keep it. Number of additional days that I'm going to keep it. I wonder if students are experiencing problems with this question because they didn't know how long they've had the steer for, but this is like we're starting right now. Now, one of the other challenges in this question is that unlike the orchard question or the, I think it was just another orchard question that we saw. Yeah, we've done 2 profit orchard questions. There's no common factor between these. So factoring at this stage isn't an option. It's really important that we recognize that we're not in a factored form and we're not in a standard form. The roots of these factors would be the roots of the revenue function, but roots of these factors are not going to be roots of the profit function. I'm not in standard form. I'm not in factored form. I'm not in vertex form. I'm not in a useful format. And I'm not seeing an easy way to getting to factored form either. This is where we'll find an advantage for that, let's say, third format. We like vertex form for sketching. We like factored form for solving. I don't know if we really like standard form, but sometimes it's just plain required. So here's my plan. I'm going to expand this to get it into standard form. Then I'll be in standard form. And if I'm trying to maximize the profit, what I'm going to try to find is my axis of symmetry, and I'll see if I can think of a shortcut that I can use to get my axis of symmetry from standard form. Okay, so here comes my expanding. Now the numbers are a little bit, big, and some of them are decimals. So I'm going to expand carefully, definitely with a calculator. I'm going to do 135 times 1.65. 35 times 1.65 is 222.75. I think I'm going to take 2 steps on this one. I'm not going to do that plus that in 1 step. Let's do 135 times negative 0.01. I'll have a minus 1.35, and I'll do 3.5 times 1.65, 3.5 times 1.65. It's going to be plus 5.775, and then a 3.5 n multiplied by negative 0.1, and 3.5 multiplied by 0.01. It's going to be minus 0.035 n squared, and then I'll have a minus 0.80, I guess. See, collecting these 2 terms in 1 step has no advantage because there's going to be another term right there anyways. All right, let me get rid of the book here. It's kind of causing problems. Let's just keep track of the fact that we're asking when should this steer be sold. And yeah, I think we still have focus. So I'm going to collect my like terms. I mean, it doesn't have to be in a specific order, but I like it in the standard form order. Negative 0.035 n squared. I'm going to collect these terms here. Let's see, that's a negative 1.35 plus 5.775 minus 0.8 gives me plus 3.625 n. And then is that my only constant term? Looks like it. Plus 2.75. Okay. From standard form, let's reevaluate and say, what is it that I'm looking for? I don't really need my roots. So using the quadratic formula, it would be not a shortcut, a long cut, a detour, unnecessary. I don't plan on factoring this or completing the square either. I have a formula that gives me the axis of symmetry from standard form. My axis of symmetry is going to be n equals negative b over 2a. Let's substitute in and get the opposite of 3.625 divided by 2 times negative 0.035. Be careful with this operation. I'm going to try it. I mean, I know it's going to be a positive number because I see a negative divided by a negative, so I'll leave that out. 3.625 divided by bracket 2 times 0.035, close bracket. And I get 52. That seems high. I can check my answer later. Let's see, 2 times 0.035 is that, and then 3.65 divided by that answer. Yeah, I'm getting the same number. So unless I've made a huge mistake in expanding, I think I'm okay. So yeah, here we go. With an axis of symmetry of n equals about 52, I'm going to say to maximize profit. Profit. Sell after 52 days, or wait 52 days before selling. Okay, it might make a more, I don't know, interesting or test level question if it was just revenue, but we should be able to build the profit function. Make sure you try it out on your own.